Then we have memory, which is where the computer stores data and instructions that are currently being used. There are different types of memory, including RAM random access memory and cache. RAM is like the computer's short-term memory, while cache is like its ultra-fast memory that's used for frequently accessed data. Finally, we have input and output devices, such as the keyboard, mouse, monitor, and printer, that allow us to interact with the computer and see its output. Now let's dive a bit deeper into some of the key components of computer architecture. One important concept is the instruction set architecture, ISA, which defines the instructions that the CPU can execute. Different CPUs have different ISAs, which means they can execute different types of instructions. It's like different languages that different CPUs can speak. Another important concept is pipelining, which is a technique used to increase the efficiency of the CPU by allowing it to execute multiple instructions at the same time. It's like a chef preparing multiple dishes at the same time, with each dish at a different stage of preparation. And just to add a bit of humor here, computer architecture can be a bit like a movie set. You have different components and act as CPU, memory, input-output devices, working together to create a cohesive and seamless performance computer system. And just like with a movie set, if one component isn't working properly, the whole production can come to a screeching halt. In conclusion, computer architecture is the study of the design and organization of computer systems, and it's essential for understanding how computers work at a fundamental level. Whether you're a software developer or a hardware engineer, a solid understanding of computer architecture is critical for building and optimizing computer systems. So let's grab our popcorn and dive into the fascinating world of computer architecture. An operating system is a software that manages computer hardware and software resources and provides common services for computer programs. It acts as a mediator between computer hardware and software applications, making it possible for them to work together smoothly. Now, let's dive into some of the key components and concepts of operating systems. First, we have process management. A process is a program in execution, and process management is the act of managing processes by assigning them system resources such as memory and CPU time. This is like a movie director assigning actors to different scenes and roles. Next, we have memory management. This involves managing the computer's memory to ensure that each process has access to the necessary resources. Think of this like a movie set designer making sure that each actor has enough space and props to perform their scene. Then there's file management, which involves organizing and controlling access to files and directories. This is like a script supervisor keeping track of all the different scenes and props in a movie. Another important concept is device management. An operating system must manage the computer's various input-output devices, such as printers, keyboards, and mice. It's like a movie production manager ensuring that all the different equipment and tools are available and working properly. Finally, let's talk about some examples of operating systems in popular movies. In the movie The Matrix, the operating system that controls the virtual world is called the Matrix itself. It's responsible for managing all of the different processes and simulations that make up the Matrix. In the movie Iron Man, Tony Stark's suit is powered by an operating system called Jarvis. It manages all of the suit's functions, including weapons, propulsion, and communication. And in the movie The Terminator, Skynet is an operating system that controls a network of machines, including the Terminators. It's responsible for managing all of their functions and ensuring that they carry out their mission. In conclusion, operating systems are a critical component of modern computer systems. They provide a layer of abstraction between hardware and software, making it possible for different programs to work together seamlessly. Understanding the key components and concepts of operating systems is essential for anyone working in the field of computer science. So let's grab some popcorn and dive into the fascinating world of operating systems. Computer networking is the practice of connecting devices together to exchange data and resources. Networks can be as simple as two computers connected with a cable or as complex as the internet, which connects billions of devices around the world. One of the key concepts in computer networking is the OSI model. This is a conceptual model that describes how data is transmitted over a network. It consists of 7 layers, each of which performs a specific function.